what we all know is people think, oh, AI doesn't run on algorithms alone, right? It runs on electricity. And the objective of this session is simple but urgent. As AI scales globally, right, data centers are becoming foundations for economic growth and national resilience. And how AI infrastructure, grid integration, policy coordination can work together to build resilient economies. So today is about leadership, technical leadership, system leadership, and policy leadership. So let's explore how we can move forward. So to kick things off, I would like to invite Dan Oates on the stage, who is the acting deputy director, U.S. Department of State, Bureau of Cyberspace and Digital Policy, Office of Emerging and Critical Technology Policy. Dan.
Good morning, everyone, and I want to thank the National Lab of the Rockies for organizing this important discussion. As stated, my name is Dan Oates. I'm the Deputy Director in the State Department's Bureau of Cyberspace and Digital Policy. Our team really advances an open, secure, interoperable tech ecosystem to support economic growth, protect national security, and reflect democratic values. And today I'm going to help set some of the broader context for what are U.S. AI priorities before we dive into the infrastructure questions that will drive this panel. So as the global leader in AI development and industry, the U.S. is committed to sharing its technologies to enable countries around the world to realize the economic and societal benefits of AI. Last July, President Trump released America's AI Action Plan that reflects a fundamental truth. AI is a foundational technology that will define economic growth, national security, and global competitiveness for generations in the future. The action plan is built on three pillars. First, strengthening American AI innovation. We're promoting U.S. AI leadership to ensure Americans benefit from AI's transformative potential while avoiding overly precautionary regulation. AI systems must be built from the ground up with freedom of expression in mind. Second, we're building American AI infrastructure. President Trump signed an executive order to accelerate federal permitting of data center infrastructure, recognizing that AI leadership requires the physical foundation to support it. This is directly relevant to today's discussion around energy systems and data centers. Third, leading in international AI diplomacy and security. We launched the American AI Exports Program to promote full-stack American technology packages, and we want to make it easy for friends and partners around the world to adopt U.S. AI technologies that have been proven through performance, trust, and security. So AI infrastructure isn't just about compute, it's also about the entire ecosystem that makes AI possible, including secure, reliable energy systems. So as AI scales globally, data centers are becoming critical infrastructure and catalysts for energy system modernization. The AI race will determine not just our technological leadership, but also the balance of power and wealth of nations. It will determine whether democratic values or open markets it will determine whether democratic values in open markets or authoritarian models guide AI's development worldwide. And the US wants to partner with countries around the world to build long-term capabilities and become AI creators, not just consumers, contributing to a vibrant global ecosystem. I think the technical challenges that you'll discuss today on this panel on high-efficiency data centers, intelligent power systems, energy optimization, they're not just engineering problems. They're really strategic imperatives that shape which countries can fully participate in the AI revolution. So I look forward to the panel, and I'll turn it over to the moderator. Thank you.
Good morning. My name is Jacqueline Cochran, and I am Associate Lab Director of the National Lab of the Rockies, formerly known as NREL. And I'm really excited to bring up my panelists. Could you all please come up? AI infrastructure is scaling at an unprecedented pace, not only in my country, here, around the world. The question is no longer whether data centers will strain power systems, but whether leadership, technology, and policy can ensure that they strengthen power systems and economic resilience. So before we dive into questions, let me quickly introduce our esteemed panelists for today's sessions. Right, we will start with my old friend, Mr. Abhishek Ranjan. He is from his CEO of BSES Rajdhani Power, one of Delhi's primary electricity distribution companies, he brings deep experience in utility operations and system reforms. Next to him, another old friend, Mr. Samir Saxena, Chairman and Managing Director of Grid India, responsible for national level transmission planning and real-time system operations, where large-scale, high-density demands such as AI data centers meet grid stability and coordination. And then from the technology side, we have Somer Fukan, Director and Head of Customer and Partner Engineering at Intel, working at the forefront of compute architecture, performance per watt innovation, and hardware-software integration. And then representing the hyperscale perspective is Kartik Krishnan, Principal for Energy Projects at Amazon Web Services, where he focuses on integrating large-scale AI data centers with local energy systems and long-term infrastructure planning. And finally, we have Mr. Deepesh Nanda, CEO of TCS's AI data center business, leading the development of next-generation AI-native, hyperscale-ready data center platforms, bringing a unique blend of power sector leadership and digital execution. Together, this group represents the full AI infrastructure ecosystem, from grid planning and semiconductor design to hyperscale deployment and execution on the ground. All right, let's begin looking at how AI data centers are already reshaping power systems today and how this growth is being experienced on the ground. So I think I'll sit. Okay. Back. Okay, we're going to start with you, Mr. Ranjan. VRPL manages one of India's most densely loaded urban distribution networks. How are AI data centers changing how you approach load forecasting, capital investment, and reliability planning at the city level?
Thank you, Jacqueline, and thank you to the National Lab of Rockies for having me here, organizing this wonderful panel on a beautiful morning. See, as far as hyperscalers data centers are concerned, as of now, we do not see anything in Delhi, but in Delhi NCR, we do. For example, in Noida, there are certain hyperscalers which is maybe hardly 20-25 kilometers away from South Delhi or East Delhi. They're coming up. Now, if we do not plan them according to resource planning in the sense like grid, where it is to be sited, it is going to be a strain on the grid because the kind of gigawatt requirements from each of the hyperscaler is very, very huge. 1 gigawatt, one hyperscaler, something like that. So planning, when we do forecasting of the demand and the planning as such, it's not only from the content perspective. It's not about power as such. I mean, power can be, because India's national grid is there, which is a one asynchronous grid, as you have already done the study. I think that was in 2017, that the resource planning study that was done by then USAID. Okay. It's more about the network, the carriage part of it. Suppose you have in the heart of the demand center at 11 kV or 33 kV. In fact, 1 gigawatt will not be at 11 kV, 33 kV. These will be at, 220 kV or something like that, or 66 kV, 220 kV and above. So therefore, it is not going to impact the medium and low voltage grid, the gigascale hyperscalers. But then the way in India, how we are organized, that is central level transmission operators like CTU Grid India, or maybe state level STUs in India. At that level, the planning needs to be there, where, how and where the grid substation 220 by 66 or 220 by 33 has to be created, substation, we're dedicated to the same. Apart from this, since the base load is very, very, stable in a hyperscaler, generation sources, so would have to be also long duration, stable generation sources. In US, you're going for nuclear. India, we are just starting. Maybe it will take another 10 years, 15 years to reach there. So for the time being, there has to be a mix of approach. Are you going to dependent on grid completely, which may not be possible? So apart from grid, you should have a local, say, long duration, maybe 6 hour, 8 hour, or 9 hour, 10 hour battery storage. Some technology co-located with that center. Some captive generation as well, maybe renewable generation with solar and wind alike. Nuclear comes in later on. So in a nutshell, the planning has to be done through meticulous modeling exercise. It's not like you simply apply for connectivity, and it's not like a small connectivity. It's a big one. 1 gigawatt is a very big one. And it has to be comprehensive. It can't be piecemeal, transactional. So just like the CEA creates a national plan for transmission for normal loads, I believe there would be a national plan for siting of possible sites where the data centers can open, and that has to be pre-decided. Otherwise, it may lead to chaos and unnecessary adding of wires here and there, suboptimal optimization, and therefore the burden of tariff on the end consumers.
Thank you so much. All right, next we'll turn to Mr. Saxena. From a national system operator perspective, how does the rise of AI-driven data centers change transmission planning and real-time grid balancing? And what new risks and opportunities does this create at the national level?
Thank you. First of all, I would like to thank National Laboratory of the Rockies for inviting me and having me here today. Of course, this is a paradigm shift that we are going to see over the next few years. In fact, these are data centers we consider as very dense and intense loads that are coming, unlike bulk loads that we used to have at the distribution level. Now these would be at the transmission level, because sub-transmission they may not be able to cater this kind of requirement. In fact, the scale at which these are growing presently, by 2030, the size of data center penetration would probably be something equivalent to that of one of the state demands that we are seeing, maybe 8 to 10 gigawatts. So even that size is going to be very significant. Now this load is manifests on the grid. It is variable, it is spiky, it has sharp ramps, and it is so much variable. And in fact, there are silent exits also from the system. Anything happens on the grid sides, the data centers prefer to quietly isolate themselves. They are inverter based. So a big chunk of load like 1 to 1.5 gigawatt, or maybe a couple of gigawatts simply walking out of the system quietly creates a disturbance kind of situation for the grid. And we need to plan for it. We need to be able to handle this in a more planned manner rather than having it in a random fashion. So from our operator's perspective, the planning for the infrastructure, firstly, it has to be very reliable. Robust transmission system has to be there. Uh, Along with the connectivity, like I think Abhishek has already mentioned, reactive power compliance, fault right through, all those kind of things must be put in place. That is one side. The other side is the resource adequacy side. Such large chunks of demand, they must be made obligated to meet the resource adequacy requirements, not only in terms of the primary energy requirements, but also for the reserves and balancing requirements. So here comes scheduling, forecasting and scheduling. I understand that the AI, especially during the prompt phase, that we understand that it is highly unpredictable. So forecasting and scheduling would be a challenge for these entities. And here again, I believe that this is something that needs to be handled at the demand side itself, because everything cannot be passed on to the grid. The grid cannot absorb all these risks. The other side, I think, is another important aspect is that uh, many jurisdictions across the world require these data centers to come mandatorily with some sort of generation to be able to handle these variations and uh, ensure adequacy part of it. So I think in India also our systems and the codes and standards need to evolve further to be able to cater to this kind of new requirement before this I mean, a large chunk comes into the system. And of course, energy storage and all need to be integrated with that. So I would stop at that. Thank you.
I'm just going to add that our laboratory partnered with Grid India 10 years ago, and it's amazing how many comments now today are similar to back then, right? It's like, how do you plan for all these changes for something large that's variable, that's coming on the grid, that has impacts to the grid? And it's a lot of the same tools today that we were using then, like what regulatory changes, what new balancing structures. So but one thing that gets me really excited is that India has had so much change in the last 10 years. And so it's very exciting to think of how easily you're going to manage all these changes going forward. Okay, so now Mr. Fukan, as AI workloads explode, how is Intel improving performance per watt at both the chip and system level? And why does that matter for data centers operating at scale?
So I think in this whole scheme of things, the silicon providers are the problem child, right? They are the ones that are creating this whole power issue, right? So I think from an Intel perspective, we are trying to address it at 3 levels. First, of course, is at the silicon level itself. So if you look at the 18A process, if you're reading about it, we have introduced 3 technologies, okay? First one is called ribbon FET. So what's happening is that it allows the stacking of the gates closer to one another. So it essentially allows to switch transistors at lower voltages. That A reduces power. That's kind of one. Second, we're also introducing something called Power VIA. So typically in silicon design, for those who are interested, the complexity of power and data lines is very, very kind of interdependent. So with Power VIA, we're able to get the power on a back plane rather than a front plane. It is increasing the efficiency of the silicon by 15%. So that's kind of number 2. The third piece that we talk about is something on packaging. We have something called Foveros that's reasonably popular right now across hyperscalers as well, if you see. What it does is that it allows the stacking of memory and silicon. And if you really look at power generation in a silicon level, the I/O between the memory and silicon is the biggest thing that comes in. Okay, so to be able to put it together, it reduces the I/O distance, hence reduces the power. So these 3 things at a silicon level on 18A is something that we are introducing in the platform. Now coming at a system level, right? We have always been a big proponent of heterogeneous AI. Every workload does not require the guzzlers of GPUs and accelerators we talk about. So Intel has something which we call as appropriate silicon for the workload, including custom silicon. So we work with platform providers and hyperscalers to say, based on your workload, what silicon do you need? Right? Including, for example, a lot of workloads can run on your PC client nowadays. If you're able to distribute that workload across the kind of silicon you want to use, that's a second thing on power you really want to do. Right? The third thing, of course, is the workload itself, and AI is a problematic workload. But if you really look at this workload, and what you really need is observability. So I'll give an example, okay? We ran a workload end to end across CPUs and GPUs, as an example. The end-to-end latency when you run on a mix of CPUs and GPUs is about 15% or 15 seconds between end-to-end. Start from where you have the CPU and where you have the end output. But if you take a single task, so which is very comparable to run it on a CPU versus GPU mix, heterogeneous, or just or just a GPU mix. But if you want to just compare a single component saying, hey, what is my training workload on this? Right? Obviously, the heterogeneity doesn't work. So the way we are looking at is these 3 things, right? A, transistor level, make sure it counts. B, workload at a system level. You're talking about the designs or custom silicon to be able to meet the workloads and power requirements that you have. And third, work with the customers and partners so they understand this heterogeneity and be able to dissipate the power so that people treat us less as a problem child but more as a problem solver.
Thank you. Okay, Mr. Krishnan, as AWS scales AI data centers globally, how do you decide where and how to deploy AI data centers so that it aligns with local energy systems, regulatory environments, and long-term economic priorities? What has worked and what hasn't worked?
First of all, thanks to NLR for this opportunity. Good discussion to have, right? And at the right opportunity. AI is just scaling in India. It's not scaled yet. A lot of these problems are in the future. So we are not facing it today. We might face it 18 months, 24 months, 36 months from now. And we still have an opportunity to correct it or to address it. Uh, Coming to what we as hyperscalers look for, three, four things. One is speed and certainty of power. Uh, so we have our load projections, and let's say we need power in 18 months. So we need certainty that the power can be delivered in that 18 months. And then some visibility on the ultimate capacity. So let's say the data center is 150 or a 200 megawatt capacity. We obviously are not going to consume that power on day one. We will ramp to meet that demand, but we should have visibility of, hey, is there a network augmentation that needs to be done, whether that will get done on time. So that's one. Uh, Second is visibility to 100% renewable energy. So we want to run our data center sustainably. So visibility to 100% renewable is extremely important. Third that we look at is regulatory coherence. Like if a country or a state has a data center policy, there are electricity regulations, then there are open access policy, then there are certain permits and transmission planning. We see whether they are coherent. It should not happen that one is saying something else as compared to the other. And the last but not the least is certainty of power prices over a longer period. So I mean, our decisions are based on a 15, 20-year projections. And we need reasonable certainty of power prices. This is not to say that the prices have to remain flat for 15, 20 years, but we say that it has to be reasonably predictable. So that's 4 or 5 things that we will typically look at when we are setting up a AI data center.
Great, thank you. Okay, finally, Mr. Nanda. At TCS, with platforms like Hypervault, you operate where AI strategy meets real-world execution. From a systems integration perspective, where do you see the biggest gap between AI data center ambition and day-to-day operations? And how are integrated platforms helping to close that gap at scale?
Thank you very much. Very happy to be here and with this eminent panel. I think a lot has been said here in terms of how infrastructure planning is a key element of getting into the AI data center part of the business. India, as was mentioned, is very early in its AI data center journey. We have 1.6 gigawatts of data centers for sure, but those are mostly to serve the needs of edge and cloud storage. Now, as you move towards AI, the big difference, as all of us know, is the dense requirement for power. So you're looking at anywhere between 10 to 12x additional power that's needed. India, I think, is very well positioned at this point in time as compared to the rest of the world. So if I were to peg India versus the United States of America, our ability in the next 24 to 36 months to add capacity in parallel with the AI deployment that will happen in India, more for inference load, will probably be faster than what the US can do at the same time because the US is just maxed out right now in terms of power. Power both in terms of generation capacity as well as in terms of transmission and distribution capacity. So that's a big advantage for India. And that comes from the fact that the policies that the Indian government has embarked upon in the last 10, 15 years, especially on renewable energy, is now coming to fore. So we have the ability to produce renewable energy and then supply it through open access to the zones which are data center popular. Now, most of the hyperscalers, like for example, Amazon, would work around a concept called zones. Once they have established a position in a particular zone, they tend to expand in that same zone. And hence, policies that are written towards making sure that those zones are adequately planned well in advance for the physical infrastructure. Because remember, the AI models are coming at a pace which is much faster than physical infrastructure in terms of setting up a power plant, transmission lines can catch up. That gap is anywhere between 30 to 36 months, which is the issue right now in the US. In India, we have a head start because we have additional power available at this point in time. We should do well in terms of making sure that those data center zones, whether it's Navi Mumbai, for example, or whether it's Hyderabad, for example, in the next few quarters, there should be robust planning in place to make sure that those zones are adequately catered to. And then the concept of coming up with newer zones in the country. It'll be a factor not just of power infrastructure, but also how can you network these sites? Because ultimately, all the data that gets stored in these sites will have to go to an end consumer outside of the site, and hence that network connectivity is important. The other element in terms of energy systems that these large data centers will need is the element of cooling. And hence, to make sure that on day one, the planning process is very well integrated, also to ensure that the direct-to-chip cooling that will be required, just given the quantum of heat that will get generated, I think that's an element that we are working on very, very closely. So what I expect is that in the next few years, India will probably add in the range of 2 to 3 gigawatt. We have adequate renewable energy capacity. Even our pumped hydro projects probably will come in line to coincide with the build out of the data centers, and hence our ability to offer round the clock green electricity at a rate that's affordable for the term of the contract will be important. Now, what the hyperscalers need to do is that the term of the contract that the hyperscalers need to contract for utilities in India has to be long term. Currently, that's in the range of, say, 7 years, but that's not adequate. You can't recover your capital cost within that period. Then there's an optionality of extension. So, again, from a policy point of view, when hyperscalers get together, I think they need to underwrite utility capacity on power, water, and networking for that tenure. Only then you will see that these business models will become more and more predictable. There'll be a decent return for the investor, and hence that's how the sector will grow. The gap between ambition that you mentioned and what's happening on the ground right now, I think it's all about timing and how efficiently we get our planning process in place and how intelligently we design the systems. Points were made on this panel on, say, for example, battery energy storage system. It's a good concept, but then the area required for a best system as compared to the density of power needed for a backup system in that area are two different things. It's like 2x more when you use batteries. In the world of data centers, what I've quickly understood is that it's about high quality utilities. It is lesser about cost and it is about high quality utilities. Lastly, I would say is that the element of safety, for example, making sure that there are codes and standards that speak very well to all aspects of safety, not just of the data security, but the safety of constructions. These are going to be massive sites. So if you look at a typical data center rack, maybe that of, say, Intel or any of the players, it's a massive piece of equipment. Each weighs around 5,000 pounds. If you look at the architecture on power that needs to support that, there is a UPS that backs it up. At the back of the UPS, there's a large diesel engine that backs it up. At the back of that, you have two grid independent lines on an N+1 configuration. So you have so much of electrical gear that goes in. And then it was mentioned earlier on this panel that the load curve is not consistent. You have spikes, you have harmonics. To cure that, you have additional electrical equipment that goes in. And hence the aspect of safety when we write the policy or when we get together to think about what else is important for this sector to be sustainable in the long term, I think it's all elements that go around safety. And then I would say it's about quality. Third is execution. Now the expectation there is this massive race that's going on, right? Everybody wants to overtake the other person. You have new models that come up, every few weeks, right? Quote unquote, they drop a model. Now, if your rack density, as it's defined, if it changes, say, from 90 kilowatt to 160 kilowatt, physical infrastructure is not yet designed to adapt to that change. So there are big questions around obsolescence risk for physical hard infrastructure that will be put up. And hence, that's another important debate that forums like these need to discuss. Once we have safety in place, once we have gone into details of quality, once we have known about uh, at what pace we need to execute and yet not make these large assets obsolete, then is the element of cost. Again, on that parameter, I think India is very well placed in terms of cost because the cost per megawatt of build out in India currently is highly competitive. And the fact that this summit is happening in India, I'd just like to also make that case that this is the market for us to be in.
Great. Okay. So we have heard across the suite of panelists about many of the changes that are happening. But now what else needs to change? So I'm going to talk to each panelist about what they would like to see changed in terms of coordination, planning, policy, or something else that can help them keep pace with growth. Okay, so we're going to go back in the same order. All right, Mr. Ranjan, from an urban distribution utility perspective, what needs to change for distribution infrastructure to keep pace with rapidly growing AI data center demand?
Thanks, Jacqueline. And Deepesh mentioned some of the good points about design of hyperscalers and then how integrated it would be to the network and also the business models. Now, in a distribution perspective, the distribution resource planning becomes very, very important. The resource adequacy planning was introduced in India a couple of years ago, maybe 2, 3 years ago, which was mainly about the supply side. But from the network side, integrated resource planning and resource planning, distribution resource planning is very, very important. That needs to change. So that is the amendment that needs to be done in the resource adequacy regulations, the grid code, where the transmission plan should not be assumed as a copper plate. So that will give you idea about where to site flexible resources. Like in case of hyperscalers, it would be more of chemistry change. What is that? So vanadium redox. In the recently concluded India Energy Week, there were vanadium redox 20 feet containers on display, which can be, stacked up as a Lego brick. Okay, just like a Lego brick, very compact, unlike lithium ion chemistry. So, and which are long duration storage. So the chemistry is completely different. The long duration maybe 20 hours, 24 hours, more than that, the kind of base generation. So the planning needs to be changed. The grid code starts with the grid code. So just like we have connectivity regulations or GNA regulations, I think this should be classified as a mass load, as my colleague was talking about, Mr. Saxena, that, and in the connectivity regulations, they should be given a special category, and then therefore the planning would start from there. Otherwise, this may lead to chaos, and ultimately the businesses might not be profitable, or if it is loaded on the end customers, that might not be liked by the regulator as well. So instead of doing all those problems, A, the grid code, B, the regulations need to be changed, and C, the special status to this kind of load hyperscalers in the GNA regulations to be there. And then the systems are already there, and so it will be taken care of in the planning level. Technologies are there which can jump off, especially co-located generation and as balancing reserves, as Mr. Saxena was saying, and this could be co-optimized.
Great, thank you. Mr. Saxena, what about you? What would you like, what changes would be really helpful for your coordination and planning?
Yeah, so from a operator's perspective, even during the planning, we start right from the planning phase itself. The information flow as well as very close coordination from the people who are trying to put in the data centers, right from the demand, the plan, exactly what they are trying to do, and what time frame, and of course with the planning agencies as well as the transmission utilities and the system operators, it is extremely close coordination that is required. And the more important part of the planning exercise is that the models for studies, system studies, dynamic studies, all those must be very, very clearly mandated, and they must be provided by the data centers so that they are able to do that. And in fact, empowering the data centers also to be on the electrical side, also to develop expertise on the electrical side. We saw this in the RE integration phase. In the RE integration part, we saw that the developers were simply kind of trying to do plug and play. They were not bothered about the technical requirements of the grid. They were not equipped also to be able to carry out the studies, to do fault analysis, and all those kind of things and take corrective action. They were largely dependent on the OEMs. So we would like to prefer that this kind of gap is not there with such large loads. It's not affordable, in fact. So that is one from the planning side. On the operation side, very close coordination with the load dispatch center for forecasting, scheduling, balancing, providing reserves is also very important. Going forward, the data centers should be able to provide load shifting, peak shaving, maybe reactive power support also as and when required, ancillary services, demand reduction, that can also they can participate. So all these services would become important because these are large chunks and they are easily doable. You can directly have a signal sent out to them. So all those things are becoming very, very important. So this kind of close coordination must be developed, and they must come in as responsible citizens towards the grid as well. Right. Thank you.
Great. Okay, Mr. Fukan, what design or system choices across the stack from silicon to full systems most effectively translates performance per watt gains into real efficiency at data center scale?
So I think it's like in any hypergrowth market, people often overlook the need for cost and sustainability versus design. Like I think my esteemed friends represent us say now people are looking for quality versus cost. That's never true. But to be able to be sustainable, you really need to look at a design that's sustainable over time, irrespective of the cost curve. So a few things need to happen. I think if you look globally, and you are, Mr. Saxena and etc. would know more, there are, data centers out there with a PUE of 1.06, 1.1, what have you. But if you look at the India AI mission that is set up, although the goal was set there, we were not able to achieve that to be able to do, and we kind of land up at 1.3, 1.4. So step one, I think data center providers need to relook at data center design, okay, to be able to make sure can we meet the PUE from a sustainability perspective. That's one, right? What does it require? It requires, as I said, the heterogeneity of platforms that can give you the power requirement that you're talking about. You really need to look at computation and other platforms across to be able to do that. Second thing, the IO is important, and I think Mr. Nanda touched upon it. I think photonics is a nesting, right? You should be able to use newer technology like optics to be able to reduce the power and increase the transmission, what have you, to be able to meet the cost. Last but not the least, I think um, as a country or as a set of people who are looking at sustainability in the long run, the future is always open, right? Supporting for open systems, open ecosystems, for organizations to work together to meet to one common infrastructure is what has been sustainable in the technology industry. And AI is no different. So if I were to ask the conversation for scale that you're talking about, I think step one, I think the government needs to be firm about setting, PUE standards so that it reduces, Mr. Saxena's work in terms of making sure it's predictable. B, you really need to look at newer technology like optics to be able to meet the conversation of what kind of transmission power you're looking at or transmission distance you're looking at. And third, I think there needs to be, and that India has done well. We have been very committed to open source, what have you, right? We really need to be very focused on open so that we know that it's sustainable and long term versus getting locked into one architecture versus another. Those are three things that I would request it out to be for this to happen in the country.
Great, thank you. Okay, Mr. Krishnan, from AWS's experience scaling AI data centers worldwide, where do coordination challenges with utilities or regulators most often slow deployment, and what has proven most effective in overcoming those frictions?
So I was talking to Saxena ji backstage, and uh, I think the fundamental difference between traditional cloud services versus AI, I think there is a lot of confusion, there is no clarity, and I think we as hyperscalers should also do a better job of explaining that. Like today, like Saxena ji rightly said that AI data centers, the load behavior is slightly different as compared to traditional DCs, and it needs to be dealt differently. That's a fact. And so that one thing, I think it's a challenge in the sense that both of us have to come together. We have to explain that there is this difference and how it needs to be treated separately and what our expectations are. Our expectations also are slightly different for an AI data center as compared to, let us say, a traditional DC. So that's one. Uh, Second is just the planning cycle, right? As a DC, our planning horizon is 15 to 20 years. The transmission planning cycle at the state level at least is 5 years. Regulatory certainty is for 2 years. So the planning cycles are different, right? So at somewhere the planning cycles has to merge. We have to be more long term in terms of planning. Uh, Third is more policy. Uh, India has really good policies, to be honest. I think the PSG also touched that abundance of renewable, and there are multiple models of securing renewable power. There is green tariff, there is virtual power purchase agreements. We can buy RECs from the market. There is physical PPA, but uh, so let's talk about physical PPAs. State-wise, it differs. In some states, there is, let us say, monthly banking. In some states, there is time of use banking. In some states, the banking is reduced only to the solar generation hours. So somewhere this policy coherence across state should be there. It will help us to take better decisions. And uh, last but not the least is there are policies in place in terms of incentives for data centers or uh, certain waivers, but on ground the implementation of these policy is a challenge. Like that's what we have seen, that there could be an electricity duty waiver or there could be an incentive on energy rebate, but on ground actually getting that rebate, there are administrative challenges. There is a process in place, but it takes about, let us say, 18 months or 2 years to actually get those incentives. So yeah, I think high level these would be the challenges that we see.
Thank you. Okay, Mr. Nanda, as AI data centers move toward higher power densities and liquid cooling, where do traditional data center models break down? And what needs to be rethought from the ground up?
I think between the conventional data centers and the AI data centers, uh, the design philosophy is going to be very different. We're going to get together on day one between the semiconductor manufacturer, between the hyperscaler and the data center designer. That probably did not happen in the erstwhile data centers. It was more look like a building where you just go and put racks. These are going to be complex energy systems. So that's one big change that will happen, and that will happen just given the kind of power requirement. But I'll also add to the comments that were made earlier in terms of what else can India do. So India is at a advantageous position, as I mentioned earlier. Also, given the fact that we have a single national grid, not there in many countries, which also means that there is a different power price in different parts of those countries, which gives us an advantage. The Indian states currently are competing for investment on data centers, and that's super attractive. That is not the case internationally, and I hope it remains in India, till we become a force to reckon with. So, on your question of the coordination on policy, I think if all of us speak in unison with the states who are currently vying for investment and make sure that those investments are translated into infrastructure projects in quick time, I think we would have served ourselves very, very well. Third, just learning from the issues that uh, data center build out in the United States of America are facing. And I quote that example because that's the country where maximum build out is happening currently. Um, I think India has a huge manufacturing footprint right now, and a lot of that is underutilized, especially on the power side. So if you say, for example, turbines, if you take, whether it's wind turbines or gas turbines or steam turbines and so on, in the US, that's maxed out and there is no availability till 2030, 2031. Companies like, say, GE or Siemens and so on are sold out completely. We have that capacity. Same with electrical gear, right? So I think this is the moment for us, and has been said by my fellow panelists, for us to quantify by state, by location, what is the demand, and then kickstart the manufacturing process so that we have enough gear in place as this exponential growth takes off. Finally, also sources of power. So we've talked about renewables. Um, I'm also a firm believer that we will also need back of the meter power in the sense that these campuses will have to be self-sustained at some point in time. And to that extent, India should um, rethink the approach towards gas-based power generation. We as a country, we have around 45 million tons of import capacity, and that's ideally located across the periphery of the country. We have a very good pipeline network, and hence again, as hyperscalers look at the zones where they want to build out large data center campuses, it'll augur extremely well for India to kickstart the gas-based power, for these plants. Because when it comes to affordability, I think the data center operators and the hyperscalers, that may not be the issue as compared to conventional power. Because it was mentioned earlier, I think it was Abhishek who mentioned that ultimately my consumer, which is the consumer that they serve currently as a distributor, should not get impacted on the cost of electricity. That's another policy dimension that we need to work upon.
Well, we can have a whole other session on rate design, but for now, let's just, we'll have a lightning round. And so for each panelist, tell me, the theme of this is collaboration. So, of this panel. So to address any of your biggest like disconnects today between where you are, where you're going, what others are doing, what is one collaboration that could close the gap fastest? And I will take any order. Lightning round, one.
Adoption of heterogeneity or silicon diversity. I think that would be one key one.
Right.
Okay, provision of reliability services by the data centers would definitely improve the system operation side.
Taking the cue, so this is the design of the hyperscalers, the technology collaboration, which is flexible, grid integrable, just like you have electrolyzers, which can flex. So that kind of technology.
I'd say hyperscalers taking a bigger bet on India.
Which I think they already are. So I think the good and the bad thing are the same. AI data centers the power density is very high. Like in the same footprint, you're talking about gigawatt capacity. I think in the next 5 years, we'll talk about gigawatt capacity. Why I'm saying it's good and bad? It's bad because you would want the data centers to be spread out, right? So that the strain on the network is not that much, but that's not happening. Why I'm saying it is good is, the pockets that you need to focus on. Like Dipesh rightly mentioned, he spoke about Navi Mumbai or he spoke about Hyderabad. We exactly know the pockets where the data centers are coming up. And we should give special attention to those pockets when it comes to network augmentation much ahead in time, right? Network augmentation, or like Saxena ji rightly said, that there could be a problem of fault currents being injected or harmonics or voltage flicker. So the good thing is that you can arrest it at that point. Like if you put in proper checks and balances, these things can be arrested at the local grid itself, and it will not pass on to the grid. So planning, I think we have to get better at planning, more localized planning. I don't see problem on the generation side. Upstream transmission network is also robust, but when it comes to localized network wherein the data center clusters are forming, that is where I think we should collectively focus and plan better.
Wonderful. And then on our last few minutes, do any of you have a question for one of the others on the panel?
I'd like to take this opportunity to ask, so you on battery energy storage and the role that it'll play to stabilize grid power for large data center campuses. Any thoughts on that? Because that's a topic that we've been looking at, and I know that India has embarked on a journey of buying massive capacity of battery energy storage. How do you see that playing out?
So I think energy storage is definitely going to be playing a very, very important role, especially in the context of data centers. In fact, that is where you can actually absorb the ramps and maybe provide backup, provide reliability service, provide voltage support. All those kind of reliability services can also come out from the battery energy storage systems. And in fact, it could offer some sort of shifting of demand as well. So all this, I think, should definitely come through in the form of local support to the data centers.
So Dipesh, just to add, this is another commercial opportunity for you, business opportunity. So you run data centers, right? So that is your main business. But then when you add these resources, I'm talking lithium chemistry. You can talk about any other chemistry which I attributed to, maybe the vanadium redox, which is a flow chemistry. There could be many other sodium ion batteries, long duration ones, because this is a very stable base kind of load. Data centers are. So if you have this, and then the regulations which are in place, ancillary services regulations may be amended, AS market base are getting introduced, ancillary service on market is already there. Now, SRAS, that is secondary reserve ancillary service and primary, they are going to be market based in short-term short-term future. So that could be a way where you are making your lives easier. Also, there is a money spinning opportunity where in your valuation sheet, one of the line items would be how I am flexing my data centers without impacting the reliable operation and making money out of it. But next one thing, Jacqueline, I wanted to add here, as we are becoming more and more data driven, data dependent, data is just like becoming our oxygen, air. So the data centers definitely are going to be very, very crucial and critical infrastructure. As like in India or anywhere else, we are classifying the power infrastructure as very critical. And they are very soft targets. Now, the islanding schemes of power in India, for example, for cities like Mumbai, Delhi, Hyderabad, Bengaluru, where these data centers are likely to come up, they need to be brushed and dusted now. Because if the islanding schemes are not properly operating, in Mumbai, there was a case, I think, in October of 2020 or 2021, where there was a failure because of some transmission glitch. Something happened, and there was cascade failure. The hydropower in the Western Ghats were not able to sync up or, supply power to Mumbai, city of Mumbai. So those things will be catastrophic because why the data centers, if they fail, then your critical life support, your police enforcement, maybe airports, hospitals, they're all going to die down. So therefore, the islanding schemes have to be dusted, and there we need more technological inputs. It's not no longer a power play because it's going to impact your lives. Data centers are now heart of lives, actually.
Well, thank you. This has been a fascinating discussion, and it is clear that all these choices that we're making today are going to be shaping our economy for decades to come. And I want to give a round of applause to our panel. And then, okay, but others, you want to come up? I'm going to invite now my colleague Adarsh Nagarajan to give some closing remarks. And then stay for the next panel. We're going to be going more into data centers.
Thank you. Please stay back and ask your question, sir. This is a very important topic, but little later, once we end the session. कुछ नहीं होगा? Is it? We'll figure it out, sir. Oh my God. Okay, we'll figure it out, sir. Thank you. Thanks for your voice. This whole journey of AI as a data center and the load growth is so rightly mentioned by Jacqueline. What India went through 10, 15 years ago, huge change in demand. Here in this case, we are adding huge demand of gigawatt scale, adding a new state. Even a variability of 5 to 10% is hundreds of megawatts. It's huge. And as this committee so rightly pointed out, this will be successful only when there is a knowledge exchange and a handshake across all the stakeholders present here and the categories of stakeholders, the chip manufacturers as model developers, the solutions, the discoms, and the national grid operators, all put together. When there is a harmony of knowledge, that's when it becomes highly successful, organized. And I believe the leaders here have already communicated that. And with that, I want to take the next few minutes to provide the memento to all the panelists. Let me invite Jacqueline, please give the memento to Abhishek Ranjan, CEO of BRPL. The memento that we'll give. Oh, we have. Thank you. Thank you, sir. Let's have Mr. Samir Saxena, sir, please. You can come stand here. Thank you, sir. You can come in the front, a better picture for everyone. Thank you. Let's have Mr. Krishnan. Sorry, Fukan, sorry for that. Mr. Krishnan, please. Thank you. And Mr. Nanda. Thanks a lot. Thanks a lot. Please stay back. We have an equally interesting yet more technical session following. Right after this, same place, we'll be replaced with more eminent guests as well. So please stay back and listen to that as well. Thank you.